All right, think about it. We are literally surrounded by these invisible Wi-Fi networks every single day. But have you ever actually stopped to think about how they work? Well, today we're going to pull back the curtain on the so-called magic that connects our entire digital lives.
I mean, you've done it 1,000 times, right? You open your laptop, you pick a network, you hit connect, and boom, a second later, the entire internet is right there at your fingertips. It feels like magic, for sure, but it's actually this brilliantly designed system, and it all starts with something called a LAN.
So, what's a LAN? The easiest way to think about it is like your own private digital neighborhood. It's just a collection of all the devices you have in your home or your office. Your phone, your laptop, that smart TV, they're all connected and they're all talking to each other. This is the absolute foundation, the very first step to getting online. Okay, so for these devices to talk to each other, they obviously need a way to tell each other apart. I mean, think about it. How does your router know to send that hilarious cat video to your phone and not, say, your roommate's laptop? Well, it's all about addresses, and not just one, but two of them.
And that right there, that's the core challenge. You've got a local network with maybe dozens of devices, but it's connected to an internet with billions more. Sending data to the exact right place, that requires a system of identification that's super precise and totally foolproof.
And here's the solution, and it is pretty brilliant. Every single device out there has a permanent, unchangeable MAC address. That's its physical address, literally burned into the hardware. It's like a unique fingerprint. But then, when it joins the network, it gets a temporary, logical IP address. We call it logical because it's assigned by software, and it can change. I love this analogy. Think of the MAC address as your actual name, which is permanent, and the IP address as your hotel room number. That number changes depending on which hotel you're checked into, right? Same idea.
Okay, so we've got these two different addresses, one physical and one logical. The next obvious question is, how in the world does the network know which IP address belongs to which MAC address? It's got to have some kind of directory, right? A way to look up who's who in this little digital neighborhood?
And that directory service? It's called the Address Resolution Protocol, or just ARP for short. Its job sounds simple, but it is absolutely critical. It's basically the network's matchmaker. It connects that temporary IP address to the permanent MAC address, making sure the data gets delivered to the correct physical device.
And this is how it actually works. It's kind of like your computer walks into a crowded room, that's the local network, and just shouts out, "Hey, who here has this specific IP address?" That question, that broadcast goes to everyone, but only the one device that actually has that IP address raises its hand, so to speak, and replies, "Yup, that's me, and here's my permanent MAC address." As soon as that little handshake happens, your computer knows exactly where to send the data. Simple, but effective.
So, okay, addressing is figured out. That's a huge piece of the puzzle. But just directing all that traffic efficiently, that's a whole other challenge. You see, early networks, they were a complete mess. But a really key innovation came along and brought order to all that chaos. Let's dive into that evolution. And I'm not kidding, they were chaotic. Just imagine trying to have a conversation where every time one person spoke, they had to shout at the top of their lungs so that everyone in the entire building could hear them, even if the message was just for the person sitting right next to them. Well, that's pretty much what early LANs were like. And all this chaos was caused by a device called a hub. A hub was a really simple piece of hardware. It had one job and one job only. When it got a piece of data, it just yelled it out to every single device that was connected to it. Talk about inefficient, right? You bet it was. And the result was, well, exactly what you'd expect. With all these devices shouting all the time, messages would just constantly crash into each other. It created this massive digital traffic jam. And that, of course, meant super slow speeds and a really frustrating experience for everybody. But then came the hero of our story, the switch. A switch is smart. Instead of just shouting, it actually listens. It builds a little table in its memory that matches each physical port to the specific MAC address of the device plugged into it. So, when data comes in for a specific device, the switch sends it only to that one device. It's like a targeted whisper instead of a chaotic shout.
And this was a total game changer. I mean, by getting rid of all those constant data collisions, switches basically unlock the door to high-speed local networking. Things we completely take for granted now, like fast file sharing or multiplayer gaming on a LAN, suddenly became possible. Plus, it was a huge security boost because your private data wasn't being broadcast for every other device on the network to potentially listen in on.
All right,
So now we've built ourselves a fast, efficient, and pretty smart local network. But that's just our little digital island. How do we connect it to the massive global network we all know and love as the internet? Well, for that, we need a gateway.
And that gateway, my friends, is the router. If a switch is like the local post office, sorting mail inside a single town, the router is the international airport, directing packages between different countries all over the world. It's the device that sits right on the edge of your network. It looks at the destination IP address of your data, and it figures out the best possible path to send it across that vast, interconnected web of networks that we call the internet.
The thing is, this system worked beautifully. Maybe a little too beautifully. The internet just exploded in popularity, and all of a sudden, we weren't just connecting a few computers. We were connecting billions of devices. And that created a massive, and at the time, unforeseen problem.
You see, the original internet addressing system, known as IPv4, was built on a 32-bit system. Now that provides for about 4.3 billion unique addresses. And back in the 1970s, when they came up with this, that number must have seemed practically infinite. Fast forward to the 2010s, and yeah, it clearly wasn't enough, not even close. With a global population of over 7 billion people, and with many of us having multiple devices, a phone, a laptop, a tablet, we had officially, completely run out of IP addresses.
So, the solution was a massive upgrade called IPv6. I mean, just look at the difference. The old IPv4 system was like an old-school lock with a limited number of keys. IPv6, it's like a modern digital vault. It expanded the address size from 32 bits to a mind-boggling 128 bits. The difference is just staggering. We went from 4.3 billion addresses to a number so huge it's obviously hard to even comprehend. We're talking a virtually unlimited supply. And hey, as a nice little bonus, it also streamlined the whole process, making things like ARP unnecessary in a lot of cases.
And this is why all of this tech talk actually matters to you. This entire architecture we've been talking about, from the LANs and switches to the routers and IPv6, this is what makes our modern digital life possible. Things like working from home, collaborating on documents in the cloud, having video calls with family across the globe, or even just asking your smart speaker for the weather, every single one of those things relies on this invisible foundation.
So really, the next time you hit connect, remember that you're tapping into this decades-long story of incredible innovation. It's this whole system of physical fingerprints and temporary addresses, of chaotic old hubs evolving into smart switches, all working together behind the scenes to create that seamless experience that, let's be honest, we all pretty much take for granted every single day.
And it really makes you wonder, right? With billions more smart devices coming online all the time, cars, fridges, you name it, what will the LAN of the future even look like? What new challenges are just around the corner, and what brilliant solutions will the next generation of engineers come up with? It's something to think about. Thanks so much for joining me for this explainer.